Okay, so we'll go ahead and look at questions from our homework. What questions do we have now out of 1-1? Do you have any out of 1-1 to look at?
The equation, number 14.
Sure. Question 14 out of 1-1. And we have plenty of time, so if we need to work some more of them, we can as well. So anything else besides question 14 on 1-1?
What did you mean by answers decide whether the equation is conditional and all? What's the given solution?
Okay. Now, when you solve it, let's talk about equations for a moment. When we solve an equation, and it's Tracy, right? Yeah, all right. When we solve an equation and we work it through, there are 3 types. So you've got conditional, contradiction, and an identity. Now, conditional means you get a number. So you would be able to solve it for, let's say, x equals 8 or 12, something like that. Okay, so that's conditional. Identity means the sides match up. So they're the same. And that would be all real numbers for that if it's an identity. And a contradiction is where the variable x disappears, but you're left with something that's not true. So like 8 equals 4. That would be false, and you would have no solution. So conditional, you get an actual answer. So your solutions, that would be the number that you find. Identity is all real numbers, and contradiction means you have no solution. So are there any of those out of like that 9 through 11 that you'd like for me to look at and work through? Does it kind of make sense what I'm looking for now?
Yeah, do 11.
Sure. Yep. We can add 11 to the list here. Okay. Any others to look at out of 1-1?
So let's just say 13 through 20.
We can look at a few of these. How about we look at 13? Let's see, because 15 is kind of like question 14. How about you look at 15? How about we look at 17, because that's going to be another more difficult one. And we can look at one of the decimal ones as well. How about question 19? And that gives you kind of a mix of all of them. Okay? Is that going to be enough? Yep, you're welcome. What about 1-2? Do we have some questions out of those applications?
2 and 3.
Okay. 2 and 3. Remember, we did 1 and 4 last time, but we'll go over 2 and 3 just to make sure we understand how to solve those as well. Any others out of 1-2 to look at?
Can we look at 14?
Sure. 14 out of 1-2. Any others? If we find some more, we can add to the list here. Now, we did cover 1 through 6 out of 1-3. So any of those out of 1 through 6 out of 1-3 that you'd like me to look at?
Number 4.
Sure. Question number 4. Okay, are there any others? We always have time for questions because the idea behind this class is to get you ready for the next one, college algebra. So we can spend all the time that we need to make sure we understand the basics. Once you get the basics down, then it's a lot easier and there's less frustration. So we'll look at these. We can add some more. Is there any others?
I didn't really understand any of those.
Okay, so we looked at 4. How about we add question number 1, because that's an expression. And how about we add 6 as well? So that'll give you about half of them. We can add some more if we're still confused once we work through those, though. Well, let's go ahead now and get started. And once we work through some of these, then it'll kind of get back to what we're working with, and it'll start to make more sense. So we're going to begin in 1-1 with question number 11, it looks like. And when we work these out, if you ever have questions about a step, just be sure and ask. Because, again, the goal of this class is to get you ready for the next one. So if we need to stop and look at things together, we can do that. Now, question 11 has square brackets and it has parentheses. So how do we handle square brackets and parentheses? Well, if we remember, square brackets work just like parentheses. And we work on the inside and we work our way out. Okay? So we'll look at the left-hand side and then the right-hand side, and then we'll put it all together. Now, the reason why we use square brackets is because we've already used parentheses. And we don't want to use double sets of parentheses because then it looks confusing. So when we have multiple sets of parentheses, a lot of times we're going to use a square bracket. And so the first thing we're going to look at is we'll work on the left-hand side first. And we're going to work on the inside and work our way out. We'll do the innermost parentheses first. And that negative in front, that is going to get distributed through. And when we distribute through a negative, all that does is change the signs. Thank you. On the right, we'll go ahead and clear out those parentheses as well. So we use our distributive property here. And this is what we've got so far. So we just distributed that negative through on the left and distributed that 3 through on the right. Now we're going to clean up this square bracket here, and I'm going to write it with the variable first. So I'm going to leave the 2 out in front, because that's multiplication, and we do parentheses and brackets first, and then we'll use that 5R, and Tommy, right? Help as being here. Sure. Okay, and so we'll write that 5R first. Remember, it's a negative, so don't lose track. Oh, sorry, it's positive, so don't lose track of that. You can put the positive there if you want. Just make sure you don't lose signs. What about the 3 and the negative 5? Well, 3 minus 5, that makes it a minus 2. On the right, we can go ahead and clean it up by writing that 9R first. And then we can look at the negative 10 and the positive 6. So negative 10 plus 6, that makes it a negative 4. And if you struggle with positive and negative numbers, think about them like a bank balance. If I overdrew my account by $10 and I add $6, that means I'm still short $4, right? So that's the way we look at those. Now the right-hand side is already done. So the next step is going to be distribute that 2 through. And when we distribute that 2 through, we get 10R minus 4 minus R equals 9R minus 4. You can skip some steps sometimes if you need to. When I work out questions, though, I generally do not, because I want to have a good set of notes for you to go back and look at later. So I don't generally skip steps in the lecture, but you can if you feel comfortable doing that. And then what do you know about 10R minus R? Well, that's 10 minus 1, so that makes it a 9R minus 4. And the right-hand side is also 9R minus 4, right? Okay, so we have now gotten to this step. What do we know about the left and the right-hand side? They are the what? Same, okay? And if they are the same, then what is it? Identity. So this is an identity. And the solution set for the identity is all real numbers. Some textbooks use negative to positive infinity, and that's okay too. But ours uses all real numbers, so that's what we're going to be using for our solution set. And why is it an identity? It's an identity because the sides are the what? Same. And if it was equaling, let's say, x equals 9, and we were able to solve it, that would be conditional. And if the variables disappeared and we had something like minus 4 equals 9, that would be false, and we would have no solution, and that would be a contradiction. So is everyone okay with that now? Does everyone kind of see what we're looking at with those? Okay, question 13. Question 13 has a fraction in it. We want to solve this equation out. By the way, why is it an equation, not an expression? It's an equation because we have an equal sign, right? Expressions have no equal signs. Equations do. We could move that 8 over, but I'm going to go ahead and just clear out the fractions. So the only fraction that I have is a 19. So I'm just going to multiply everything by a 19. And that's going to get rid of that fraction there. So the 19 and the 19 below it, those are going to directly cancel. So that leaves you with a b. And then we have 19 times a negative 8. And that gives you a negative 152 equals. Then we have 19 times a negative 5, and that's a negative 95. So all we did was multiply everything through by a 19, because 19 was in my denominator. Now we can finish it by simply adding 152 to each side. And again, watch your signs. So we've got 152 minus that 95. That gives you an answer then of a positive 57. It doesn't ask what type, but this would be a conditional equation because we solved it and we got b equaling 57. So it would be conditional. It doesn't ask that, but that would be a conditional equation. Question 14. Very similar to 13. We need to clear our fractions at the very, very beginning. And we need a least common denominator. And so we're going to look at 5 and 3. Now, how do we find our least common denominator? Well, what we do is we start with our larger number. And so our larger number is 5. Does 5 evenly go into 3? No. Okay, 5 times 2 is 10. Does 10 go into 3 evenly? No. But 5 times 3 is what? 15. And does 15 go into 5 and 3 both? Yes. So the smallest number that I can use is going to be 15. So I found my least common denominator. So I'll put my 15 out in front. And now I'll distribute through. And when we distribute through with these fractions, what do? We divide by the number down below in the denominator. We multiply by the number on the top in the numerator. So we're going to take that 15 and we're going to divide it by 5. Well, 15 divided by 5 is a 3. And 3 times that 2 on the top makes it a 6. And we'll bring the x down as well. And we bring our negative down because that negative just comes down with it. 15 divided by 3 is 5. We have an x on the top, so that makes it a 5x then. On the right-hand side, what do we have? We have 15 times 4. And 15 times 4, well, that's a 60. And we're almost finished. How do we finish it? We can combine these together, and that makes it a single x equals now what? 60. And that is your final finished answer. And this would be a conditional equation. Is everyone kind of okay with what we did? So what did we do? We found our least common denominator, and we used that then to clear out all of our fractions. Next, we'll look at question 17. And I picked 17 because 17 is another fraction problem. And we're going to work it out here. So question 17. And there are many different ways to handle question 17. I'm going to show you what I think is the easiest way. So there are others, but I'm going to show you what I think is the easiest way. When we want to clear out fractions, we're going to make individual fractions. So this one right now is two fractions put together. So we're going to split it out into the two separate parts. So take that one single fraction bar and split it out into 3x over 5 plus 4 over 5 equals 6 over 5. Oh, wait, we have a plus there, not an equal sign. Sorry about that. So that's going to be a plus there. Okay, and then the other side is a minus 3x over 4. So we split up that one fraction into separate fractions. I think that's easier, and you're less likely to be in a hurry and make a mistake with combining the fractions. You could have combined these together here, but students might make a mistake, so we're just going to split it up, and then we're going to clear them out. And we need a least common denominator of a 5 and a 4. Well, again, 5 doesn't work, 10 doesn't work, 15 doesn't work, but 20 works, right? Because 20 divided by 5 is 5, so that comes out, or 20 divided by 5 is 4, so that works. 20 divided by 4 is 5, so that works. So our least common denominator would be 20. And how did I find that again? I took my larger number and I just started multiplying. 5 doesn't work, 10 doesn't work, 15 doesn't work, but 20 does work. So now we're going to multiply everything by a 20. And we're going to distribute through. And how do we clear them out? We divide and multiply. Just remember, divide, multiply. So 20 divided by 5, what is that? 4. Okay? And 4 times a negative 3 makes it a negative 12x. Next, 20 divided by 5 is a 4. Times that 4 on the top, that makes it a 16. 20 divided by 5 is a 4, and 4 times that 6 on top makes it a 24. On the right-hand side, 20 divided by 4, that's a 5. 5 times a negative 3 makes it a negative 15, and bring down your x. So divide by the number down below, multiply by the number on the top. Now we can go ahead and clean this up. So we're going to look at the 16 and the 24. Now they're on the same side of the equal bar, so they can go together. And we've got 16 and 24. That should make it a 40, doesn't it? You can always double check yourself if you need to, but that's going to be that 40 there. And it equals a minus 15x. Okay, now what do we need to do? We need to get the x's on the same side. Normally we get the x's on the left, but if I move everything to the left, that adds an extra step. So I'm going to move that 12x to the right to join the negative 15. And that leaves you then with 40 equals now a negative 3x. And we're almost done. So we did our moving over first, or addition and subtraction first. Now what's the very, very last thing that we do? We divide, so we'll divide by a negative 3. And then we'll rewrite it with the x on the left-hand side. Those 3's cancel there. And I'm going to bring that negative up to the top with that 40. So that makes it then a negative 40 over 3. Is everyone okay with what I did? So I moved it over, and then I brought that negative up to the top. And at the very last step, I always like to write the x or the variable on the left. One more, it looks like, out of this section. So we'll look at 19, and I picked 19 because 19 has a decimal. Now, when we talk about decimals, we can clear out the decimals. But I think that is more confusing than just using our calculator. So I'm going to work with our decimals. If you have a calculator, we can work with them. You do not need to clear them out. I think clearing them out just makes it more difficult. So this is what we've got. Order of operations, parentheses, go first. Put the calculator up on the screen so you can see what we're looking at here. So what do we have? We have a negative 0.5, right, times that 30,000. That's going to give us a negative 15,000. Bless you. Plus 0.15p, because that's our variable. Bless you. And then on the other side, we're going to distribute it through the same way. Watch the decimals. Be very, very careful with the decimals. Make sure you add the correct number of zeros. So it's 0.02 times your 30,000. And that gives you then your 600. I know it's hard to see on the screen, but that'll come out to be that 600. And then we have 0.02 times p, so that's 0.02p. So now we have gotten rid of all of our parentheses, right? So we just used a calculator, we distributed through. Now what do? Well, we need to get the variable, usually on the left. Everything else goes to the right. And you can do it in one step if you would like. I'm going to do it in two just so we can keep track of what we're looking at. So I'm going to move the 0.02p over. And why did I do that? Because I want my variable p on the left. So then we have a minus 15,000 plus, and watch your decimals here, 0.13p, and that equals your 600. We're going to go ahead now and add your 15,000 to both sides. And again, be careful with your decimals here. Move that over. And that gives you a 0.13p equals. These are going to be added together. So that's, so we got 15,000 plus 600. So that should be 15,600 here. And what's our last step going to be? Divide by 0.13. And that should leave you with your final answer. Then we just use our calculator here. And we've got 15,600 divided by 0.13. That gives you then 120,000. So P is going to equal 120,000. All we did was used our calculator. You could, again, clear out the decimals, but I think that's way more confusing than just using a calculator. So that's how we work out that question. When you use the calculator in decimals, make sure you're very, very careful about zeros. Make sure you add in the correct number of zeros. A lot of times what happens in mathematics is students understand how to solve things, but then they get confused with the extra zeros. Sure, yep, no problem. Yep. If you need to use the restroom, you can do that. So is everyone okay with that? Okay, so now we'll move on to 1.2. And 1.2, we did 1 and 4 last time. So we're going to go ahead now and look at 2 and 3. On your exam, you're not going to have a question that is this difficult.
No, we did 1 and 2 last time.
Did we do 1 and 2? Yeah, I guess we did. So how about because if you look back at the notes, I think you'll find 2 in there. So we'll do 3 instead. Couldn't remember which ones we did. So we'll do 3 instead. Okay, now, what are these? Well, these are what are called literal equations. And literal equations are equations that have more than one variable. So I have to tell you which variable to solve for. And students always struggle with these. You'll see them again in college algebra, but we're kind of learning them for the first time. We need to solve this for the variable p. So what I like to do is take a moment to find all the p's. So here we are. We're going to put a box around it. I think this is the easiest way to work out these literal equations. So we've got a box around all of the p's. Now let's talk for a moment about our goal. What is our goal? Our goal is going to be to get all the p's on the left-hand side, all the numbers that do not have a p on the right-hand side. So everything that doesn't have a p is on the right. Everything that has a p is on the left. Then we're going to factor out that variable p, divide, and finish. So what we can do is we can move that TP over. So it'll join that 8P. And we don't need that 8S. So I'm going to go ahead now, just to save one little step here, and subtract off that 8S. So we moved things over. Now let's see what we've got. The 8S's, those are gone. So what do we have? We have 8P, because those cancel. Then we moved over the minus TP. That's what we want, because those both have the variable P, and they're on the left. On the right-hand side, then what do we have? Well, those can cancel here, so the TP's are gone. And we have a minus 8S minus 8. So all I did was move everything that had a P to the left-hand side. Everything else went to the right. So this 8S needed to be moved over with subtraction. And that TP needed to be moved over also with subtraction. So I move them around. Now, whenever we move things across the equal bar, what happens to the signs? Signs switch. So this TP was positive. It needs to go over here, so I used a negative. Now, look at what we've got on the left-hand side. These all have the variable P. Since they both have the variable P, and that is what we're solving for, we're going to factor out that P. So we're going to put the P in front, and then what's going to be left over? If I factor out that P, I'm left with an 8, and that P comes out, and a minus what? T. And what does that then equal? Minus 8S, right? Minus 8. We've got one more step. How do we get that P by itself? Well, how does that P relate to our parentheses? It relates to the parentheses by what? multiplication. So what undoes multiplication? Division. So we're going to divide both sides by a minus 8t. And then we are finished, because those can cancel. And that leaves you then with p equals now a minus 8s minus 8 over 8 minus t. And I know this is a very difficult question. You're not going to have anything this difficult on your exam, but you need to kind of know how to work them, so when you see them again in college algebra, you'll kind of know where to begin. So is everyone okay with that one? Does everyone see what we're doing there? And so I think last time we did 1 and 2. We did question 3, so 4 is going to be left for you to do. To do 4, look at question 1. It's almost identical. Question 14. So question 14, we're going to need a formula. So question 14 says, find the surface area of a cylinder with a radius of 5, height of 30, and use 3.14 for the pi value. So we're going to go ahead and look in the back cover of our textbook, and we're going to try and find the correct formula. So we want a cylinder. So we want a right circular cylinder here. And this is our formula. Surface area is S equals 2 pi RH plus 2 pi R squared. So that is going to be the surface area of your cylinder. So we'll write up the formula, plug the pieces in, and finish it. So we know we're working with a right circular cylinder. Looks like a tin can. That's what it is. It's just basically a can. Our formula then is S equals 2 pi RH plus 2 pi R squared. Now, we don't use units of measure until the very, very end. So don't worry about units until the end on this question. We do know our R. R is the radius. And our radius in this case is 5. Our height is 30. And we're going to use 3.14 for the value of pi in your calculator. So it says specifically to use that. If it doesn't, then you can use the pi button on your calculator. This one says use specifically 3.14. So that is then S equals 2 times 3.14 times 5 times 30 plus 2 times 3.14 times 5 squared. We're going to go ahead and work out first our multiplication. Okay, and we'll do that power. So we can go ahead and do all this at once here. So just use your calculator to do all that at once. And let's see what we've got. We've got 2 times that 3.14 times 5 times 30. So that first piece comes out to be 942. Now, on the second one, order of operations. You've got to be careful with what we do. Before we multiply, what goes first? Powers do. So we've got 2 times 3.14, and the 5 squared, that goes first. So 5 squared is then what? 25. And in some calculators, you can write all the way in, the way it is. I'm going to just do step by step. So then we have 2 times your 3.14 times your 25. That then comes out to be 157. We add those up. So 942 plus 157. Adding those up, we get 1,099. Whenever we work with an area, area has square units. So lengths and widths, so it's like a ruler. They're not squared. But when we talk about area, they're squared. Volume, they're cubed. So this is a surface area. So that means our answer is going to be in centimeters squared in this case, because that's an area. Is everyone okay with that one? So let's see what we did on that. So we found the formula. We plugged the values in. We were careful, followed order of operations. Because with order of operations, we do our square first, then we multiply, add it at the end, and that gave us our final answer. Did we have any others out of 1, 2 to look at before we move on to 1, 3? Any others? We've got plenty of time.
You can go over 16.
Sure, we can look at 16. Okay. And I believe that 16 is a loan payment schedule. So on question 16, this is something that you probably won't calculate, but the dealer might have to, or the bank that writes the loan for you. We know if we pay off a loan early, what happens to the finance charge, the interest that we should have to pay. Well, if you pay off a loan early, our finance charge, our interest is less, so we save some money. Now, there's a quick formula that we can use to figure out how much money we'll save. And that's going to be based upon how long the note runs for, how many months we have left to pay it off, because the more months we have left, the more money we'll save, and then how much that original finance charge was. So we've got U equals F times K, K plus 1 over N plus 1. Now, U is the unearned interest, and that's the money that we saved. Then we've got F, which is the finance charge. So anytime you sign the paperwork for a car loan, there's going to be a finance charge in there. It'll tell you in that contract how much that finance charge is. If you pay it off early, then your finance charge will be prorated out. Then we have K, which K is the number of payments that we have left. To complete the note. And we have then N, which is the total number of payments. Now we're going to read through question 16, and we're going to try to identify the different parts for this question. So the finance charge on a loan taken out by Ivan is $666. I'm just going to write the numbers over here. So my finance charge is $666. So that's how much the finance charge is. So if I don't pay any extra payments, I'm going to have to end up paying $666 just to hold the loan. That's all that is. And so that's what the bank would make off of your car loan. There were 48 equal monthly installments. So that's going to be your N. So we're running this for 48 months. And maybe we got our taxes back and we want to pay this loan off. And we have 8 months left. So in this case, K would be 8. So N is the total number of payments. There's 48 monthly payments on this loan. We've got K equals 8. So we have 8 months left on the loan. So we took this loan out. We've been paying on it for a long time. We've got 8 months left. And let's say we just got our taxes back, so we want to pay off that loan. So we've got 8 months left. And how much money would we save by paying off that loan? Well, we plug our values in. And that's 8 plus 1 in the numerator. And 48 times 48 plus 1 in the denominator. Take your time. Don't make a mistake with this. So the f stays the same. Now, we've got 8, and 8 plus 1 is 9 over 48, and 48 plus 1 is a 49. Is everyone okay with that so far? Now, we want to divide at the very end. If you divide too early, you'll make a mistake, and you'll be off by a few cents. So we want to make sure we don't make a mistake. So the last thing we do is divide. So we're going to multiply across. So I'm going to make that 666. We're going to make that over 1. So multiply across the top. And you get then that 47,952 in the numerator. In the denominator, we have 1 times 48 times 49. That's 2352. And then we just divide 47,952. Divide that by 2352. We're going to round to the nearest cent. So it looks like we would save $20. And it looks like if we round, 39 cents. If you divided too early, you might be off by a few cents. So always divide at the very, very end. Multiply first, divide at the end on that one. So is everyone okay with that? So if we paid that loan off with 8 months left, we would save $20.39. Okay? Any other questions out of 1, 2? Is that going to take care of most of those things? Okay. Yep. Then we'll look at some questions out of 1, 3. Then we'll take a break, and we'll come back, and we'll finish up 1, 3 today. So let's work through some more questions out of 1, 3 quickly. And then we'll take a short break, come back, and finish up 1, 3. So we're going to look at question 1 out of 1, 3. Very, very important when we read through these applications. We need to make sure we read the directions. So it says we want to translate that verbal phrase into a mathematical expression. Now, what do we know about expressions? Do expressions have equal signs? No. So this is not going to have an equal sign. So we already know that we're not going to be able to solve it. We're going to have an expression, so we're going to have no equal sign. Then we look at the key words here. The product of 3 more than a number and 4 less than a number. So product. Now, what does product mean? Product means multiply, right? Okay, so that means multiplication. Product of 3 more than a number. Now, this and right here, that's going to separate out the 2 parentheses. So product means multiply, goes with the and. 3 more than a number. So break it up. 3 more than a number. What would that be? 3 more than a number would be x plus what? X plus 3. So that's 3 more than a number. Now the and is going to separate the parentheses. And we want 4 less than a number. So 4 less than a number. Now make sure you're careful with the order. 4 less, that means 4 minus. So that minus is going to go here. And what are we taking that 4 away from? We're taking that 4 away from the number x. So that's why it's going to be x minus 4. Because we're taking 4 off of that number. And that's all we need to do. We're just coming up with our expressions. Product means multiply. That's why this is multiplication. So all we can do is just write them out with parentheses, and that's it. Question 4. These are an equation. Okay, so these, when we read our directions, says it's an equation. So when we have an equation, we're going to be able to solve it. So we're going to get our equation, and we're going to be able to find the value of x. So we know we're going to have an equal sign. If 6 times a number is added to -4, the result is equal to 10 times the number. So let's break this down slowly. 6 times a number. When I say 6 times a number, what does that mean? Multiplication, right? So that would be 6 what? 6x. So there's that. I'm going to take that and I'm going to add that to a -4. We don't have to write the double signs. We're just going to add to it a -4. So we're really doing what? Just subtracting off 4. So we're going to add that -4 to it. So that -4 will go on the end. The result is, when we see result is means equals. So we have the equal sign here for that. And then we have it equaling what? Equaling 10 times a number. So that's going to be what? 10x. Now we have our equation. We can solve it. So move things around. I'm going to move that 6x over with subtraction so that it can join the 10x. So then we have -4 equals now 4x. Moving it over. We'll divide by 4 to get rid of that. And we'll write our variable on the left. So we have an x. And what does x now equal? -1. Here's your answer for that. The tricky part was just setting it up and understanding what the words mean. So sum, what does sum mean? Add. Quotient means what? Divide. Product means multiply. Result is means equal. And sum means add. So make sure you know the different terms there. Question 6 is another one of these. We're going to have to set up the equation for. Very, very similar again. 4 times a number added to 8 times the number equals 60. So break it up. Break it up into smaller parts. 4 times a number. When I say 4 times a number, what does that mean? 4 times a number would be what? 4x, right? So that's going to be the 4x there. And then what are we doing? Adding it. So we'll put our addition symbol there. And what are we adding to it? 8 times a number. So 8 times a number would be what? 8x. And it equals, so we use our equal sign here. And what does it equal? 60. Now we can finish it. So 4 plus 8. Add those together. That's a 12x equals 60. We'll divide by our 12. And that should then leave us with our final answer of x now equaling what? X should equal 5, shouldn't it? So there's your final answer for that. Now let's go ahead and take a short break, and then we'll come back and we'll look at more questions out of 1-3. So let's meet back here at about 9:40. So let's be back here at 9:40, and then we will cover more out of 1-3.